Hello friends, this video on alcohol, phenol and ether part 7 is brought to you by examfear.com. No more fear from exam. I think the last slide on the IUPAC name. Again here I'll ask you to pause for some time and try to solve on your own. If not, you can refer this. So this will be my first position because it is ethoxy group. 2, 3, 4. So I have ethoxy group and methyl group, right? Ethoxy and methyl group attached to cyclohexane. So A, B, C, D, E comes first. So it will be one ethoxy, 4,4-dimethyl. This is cyclohexane, correct? Let's see this. This is pretty easy. I have a ethoxy group attached to a benzene, so it will be ethoxybenzene. So let's study the structures of alcohol, phenol, ether. Before we start, I'll tell you the one thing. The normal angle for a tetrahedral is 109 degree. This is something which we know. We have learned this in the earlier classes. Tetrahedron, right? So if you take the alcohol, the angle between this angle COH is 18.9, slightly less than 109 degree. Why? Because there are two lone pairs, right? So because this lone pair, there is a repulsion by this lone pair, and the angle is little less than 109 degree, right? The unshared lone pair of electron of oxygens will pull these OH and OC bond, and the angle will be little less than 109 degree. This is the structure of methanol, and this is how 3-degree structure of methanol. If you see, this is 108.9 degree. This is O and this is H. This is carbon, and you have hydrogens here. This is the typical structure of alcohol. Correct? The angle is slightly less than tetrahedral angle. Why? Because of the repulsion by lone pair of oxygen, electrons of oxygens. Correct? So here the carbon is sp3 hybridized. You see this carbon, 1, 2, 3, 4 bond, sp3 hybridized. The next is phenol. Phenol, the angle is exactly 109 because there is an equal repulsion on both sides. So the angle is exactly as tetrahedron, 109 degree. Correct? Now here also if you see this carbon is sp2 hybridized. 1, 2, 3. Now here one more thing, if you see, since the carbon is sp2 hybridized, it has more s character. It will try to attract oxygen more towards it. Thus the bond length, the CO bond length will decrease. Here we see the CO bond length is 142 picometer. This is 136 picometer. Also one more reason why the CO bond length decrease here is because it has partial double bond character. Right? There's partial double bond character, so this bond length is less. This bond length is more, right? The CO bond length typically is 142 picometer. Here it is less. Why? One reason is carbon is sp2 hybridized. It has more s characters. It tries to attract oxygen towards more. The binding is more, right? The binding is more because the more s characters, so the bond length is less. The one more reason for the less, or one more explanation for the lesser bond length of CO in the case of phenol is it has partial double bond character. If you see the resonance structure, you'll see that it has partial double bond character. It is sp2 hybridized. This is the typical structure of phenol. These are all carbon here. The white ones are all hydrogens. And this is my oxygen. And this is exactly 109 degree. The next is my methoxymethane ether, making one ether. So here we see the bond angle is more actually. The bond angle is more than 109 degree. And if you see the bond length is almost same as methanol, 142, 142. Right? Because there is no partial double bond character here. Right? And why this angle is more? Because there are two bulky groups here, right? Since the bulky groups are there, they'll repel each other. Since this bulky group repel each other, the angle increased. Correct? there are two bulky groups here, maybe alkoxy or aryl group, I don't know, alkyl or aryl group. So because of the bulky groups, they repel each other and the angle increase. Correct? So it is typically 109. Since the repulsion is there, it becomes like this. So this is the typical structure of my ether here. I have oxygen here, I have carbon here, and hydrogen here, or hydrogen or any alkyl or aryl group here. Let's take some more numerical now. So we'll start with this. This you see here is my longest chain here, and I can number 1, 2, 3 in this fashion, 1, 2, 3 in this fashion. But if I number in this fashion, I cover more methyls here. I mean 1, 2, 3, 4, 5. I'll show you both ways first. Let's suppose I take this guy, then I have 4, 2, 2 methyl. That is 4 plus 2 methyl, and 3 alcohol. If I take this, then I have 2, 4, 4, 3. 2 plus 4 plus 4 plus 3. Obviously this is more, right? This is 13 and this is 11. So this will not take, we'll take this option. Correct? Now this is done. It's pretty easy now. I have methyl and I have methyl as substituents here. So 1, 2, 3 methyls at 2, 2 and 4 positions. It is 2, 2, 4 trimethyl, and longation is 5 pentane. At third I have all group, pentane 3 all. Similarly this also, the longest chain is this, or you can take this, all same. Now I have number, I can number in this fashion, 1, 2, 3, 4, 5, 6, 7. So in this case I get 2, 4 and 5, right? Position 2 plus 4 plus 5. If I number in this fashion 1, 2, 3, then I'll get 3 plus 4, 5, 6. So this is more actually, right? This is 13, this is 11. So I'll take this pattern only. Now if I take this pattern, I have ethyl group at 5th position. So it is 5 ethyl, and then 4 at 2 I have alcohol. So I'll do that later. The longation is 7, that is heptane, and 2 and 4 I have or diol. So the way it works is OH is my primary. I'll write it later here, and apart from that, all the other substituent which I have, in this case the ethyl group, I'll write before. Let's try to name this compound. Again, this is my longest chain, and I can number in any fashion because it doesn't matter, it's all symmetrical. 1, 2, 3, 4. So it will be butane 2, 3 diol, right? Butane 2, 3 diol. Why I'm writing this as last? Because this is my primary functional group. Let's take this here also. This is the one, and these are all my OH. So I'll write at the last. So it will be, number it 1, 2, 3. So it will be propane 1, 2, 3 triol. Correct. Let's take this example. This is a phenyl group, and I have a methyl group attached. This is 1, this is 2. So at 2 I have a methyl group attached, 2 methyl phenol. Right? This phenol was my primary thing. On this at 2 I have a methyl group attached. Same thing here. 1, 2, 3, 4. At 4th I have a methyl group attached for a phenol. So it will be 4 methyl phenol. Correct? Let's see this. Here also this is a phenol, and in phenol I have at 1, 2, 3, 4. Or the other option is 1, 2, 3, 4, 5. 2,5 is one option. Sorry, this will always be 1. 1, 2, 3, 4, 5. Yeah, 2,5. You can take this where this will always be 3, 4, 5, 6. 2,5 or 3, 6. Two options. We number in this fashion 1, 2, 3, 4, 5, 6, 3, 6 or 2, 5. 2, 5 is better than 3, 6. 2 plus 5 is 7. 3 plus 6 is 9. So I'll take it 2, 5. So it is 2, 5 dimethyl. And this is phenol. 2, 5 dimethyl phenol. Correct? Let's take this. This is my number 1. So I have to again number this either in this fashion or in this fashion. It will be all same. So it will be 2, 6 dimethyl phenol. Because at 2 and 6 I have a methyl. 2, 6 di methyl and the group is phenol. Let's see this. I think we have seen this example earlier. So this is my primary group, primary part, because it has more carbon. Now in this, at one position, 2 and 3, at one position I have methoxy group attached. So it will be 1 methoxy. At 2 I have a methyl group attached. 2 methyl. Meth-ith-pro. So it's propane. Correct. Let's take this. This is my primary here. So at benzene I have a ethoxy group attached. So it is ethoxy benzene. We'll take this C6H5 at ortho position. I have a N heptane attached. It is N heptane attached at ortho. This is an N heptane attached. This is the ether actually. N heptane this side and C6 phenyl this side. So this is a longer chain. This is my primary one. Correct? Please note this has 7. This has 6 carbon. This is my main. This is my primary part, right? This is the main one. So at 1 I have a phenoxy group attached. So it will be 1 phenoxy and then 7 carbon. So it's heptane. Please note it is not 1 heptane or heptanoxyphenol. We should not take this as primary. This has to be primary because it has 7 carbon. Let's take this. This is my primary, 4 carbon. This is 2 carbon. So at 1, 2, 3, 4. At 2 I have ethoxy group attached. So 2 ethoxy. This is butane. 2 ethoxybutane. Thank you. Visit our website examfear.com to watch more and more quality educational videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.